All right. How many bugs do you need to rent out an apartment? 10 nants. 10 nants. All right. Let's go. We are continuing on with our differentiation, all that good stuff. We're going to have some new tools in our belt soon. Coming up is we have these special rules. We have chain rule, product rule, quotient rule. Today, we're going to touch on the chain rule. Now, yes, look at that. I did draw a chain. That is a chain. Now, what is it for? We're going to use this rule to help differentiate brackets with powers. So I want you to start programming in your mind. If I see a bracket that's raised to a power, we can use this chain rule to differentiate. Here's the theoretical formula. We do use this later on, but for now, I think it's a little bit more confusing than it is helpful. But it's good to know, especially if you do extension 1 and further on. This is the practical formula that I think is a lot more manageable for now. Now, take a look. If y equals some sort of function, and I'm raising that whole thing to a power, the derivative now becomes, power comes down to the front as usual, take away 1 from the power as usual, bracket stays the same. And then the only difference now is I multiply it by the derivative of whatever was in the bracket. Okay, let's try this out. Let's see how we go. So if I'm differentiating this, fx equals to x plus 1 to the power of 7, let's just double check here. I've got something in a bracket and I've raised it to a power. Okay, so in other words, let's pick a pen. Okay, that means our derivative, let's remember the rule. Power comes down to the front, bracket stays the same. You take away 1 from the power, and then you multiply it by the derivative of my bracket. What's the derivative of x plus 1? That's a nice one, it's just 1. So in other words, my derivative is just 7 times x plus 1 to the power of 6. So far, so good. But what happens now when we kind of have something different going on here? So now I've got fx equals to 4x minus 3 to the power of 10. Same deal. I see a power, or I see a function, and I'm raising it to a whole little power. So I know for f dash x, power comes down the front, bracket remains the same. You take away 1 from the power, and now I multiply it by the derivative. And what's my derivative of 4x minus 3? It's going to be 4. Okay, so from here, I can see the 10 times 4 gives me 40. And I can just write this as 4x minus 3 to the power of 9. That's my derivative. Let's try another one. What if I have something that looks a little bit like this? Okay, I've got a 5 on top and I've got an x minus 3 to the power of 7. Essentially, this is the same thing as 5. And because of the negative indices, I can write this as x minus 3 to the power of negative 7. Okay, so now I've got that. Let's do my f dash x. The minus 7 comes down to the front. Minus 7 times 5 is 35. I'll have x minus 3 and take away 1 from the power. So minus 7 take away 1 is now take away negative 8. And then I need to multiply by whatever's the derivative of my bracket. The derivative of x minus 3 is just 1 because my x will differentiate to 1. And this becomes my whole new answer. And again, I like to leave my answer in the same form as the question. So I'm going to write this as x minus 3 to the power of 8 as a fraction like that. Hopefully that's okay. Let's go for a couple more. I think this could be my last one, actually. Very similar to before. I have a fraction and I've got a bracket with a power on the bottom. So I'm going to see if I can rewrite it as a negative indice. Okay. And let's do this now. So again, for the derivative, power comes down to the front. So minus 4 times 3 is minus 12. My bracket stays the same, x squared plus 3. I take away 1 from the power. So minus 4 take away 1 is negative 5. And then I multiply by the derivative of my bracket. Derivative of my bracket is 2x. So here I go, what's minus 12 times 2x? That is minus 24x. And then I'll have this x squared plus 3 to the negative 5. And again, to leave my answer as similar as I can to the question above, I'm going to write the x squared plus 3 to the power of positive 5, but on my denominator. Okay, I think that's it. Yeah. Okay, cool. That is it. Have a good one, and I'll catch you guys next lesson. Bye-bye.